Okay, gang, we are still working on question 21. It's a really good question, so let's go back to it. Now we're going to do part B. So we have to figure out, find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall. Okay, so now we're looking at the area of the triangle. So let's go back to... Okay, so before I start this, let me be really clear so you don't get confused. All these parts, A, B, C, are interrelated, which means that all the information you find from the various parts are usable in the other parts because it's all referencing the same exact scenario. Okay, just want to be clear on that. All right, so for part B, it's the same scenario. You have the ladder leaning against the wall. So let me just redraw that, a fresh copy of that. All right, but unlike the previous time, we now want to talk about the area of this triangle. All right, so that means we're going to be formulating a different equation. Do you remember the equation for the area of a right triangle? I'm trying to remember when you first may have saw that, maybe intermediate or pre-calc, right? Let's just do the general formula first of a triangle, right? The general formula is area is 1/2 the base times the height. That is the general formula for the area of a right triangle. So in our case, in terms of our variables, the base is x and the height is y. So for the variables we're using, I'll write it as 1/2 xy. Okay. All right. Now this is the equation off of the general graph, right? This is still our general graph. And let me remind you of our specific graph that we got in part A, just in case you forgot, which I'm sure you didn't. That would just be my brain. My brain is always forgetting stuff. All right, let's just write that down so we have it, because they are, if you noticed in part B, they are using 7 feet from the wall. So we're going to stay with the 7 feet from the wall. So if this is 7 feet for x, we've already solved for y, right? We did the earlier we solved for the y. So that's going to be the 24 feet. And we know that the size of the ladder is 25 feet. So we already solved this from part A. So I just carry it over. All right, so we know the general, we know the specific for this case because they are in the question saying use 7 feet for the specific. I just pointed that out if you need me to say that one more time. The specific, the freezing of time is the 7 feet when we're frozen in time. All right, so the equation came off the general. Let's go ahead with the derivative. Now the derivative's a little fancier here, right? Because you have a variable times a variable. You have the x times the y. So what rule do you have to use if you have that kind of scenario? Right, you got to use the product rule. So we have to use the product rule as we do the derivative here. And do not forget to do the derivative of a. Okay, so the derivative of a in terms of time, right? Everything's in terms of time here is dA dt. When I do the product rule, I'll take the 1/2 with the a, just so I don't lose anybody. I'll just tell you how I'm doing it. I'm taking the 1/2 with the a. So product rule, first part. So I'm doing the 1/2 with the x. First times derivative of second. Derivative of second is dy dt, right? Keep it in terms of t. Plus now second times derivative of first. So that's going to be 1/2 dx dt. Right, everybody's a function of time, right? A is a function of time, x is a function of time, y is a function of time. Right, we're doing things in relation to time. I just want to make this look nicer, so I'm going to factor out the 1/2 back out front. You don't have to do that. Do it the way you like it. I'm just going to put the derivatives in the back. Okay, My brain just happens to like this. I changed a variable, and I'm sure you guys noticed that, and we're having a heart attack. I'm now fixing it. Yeah, if I ever make a faux pas, just give me a moment. Sometimes I catch it. If I don't catch it, I try to redo the video. All right, so that should have been a DADT. All right, so in this case, we are looking for the rate of the area when the bottom is 7, when the base is 7. So we are looking for the rate of the area. So we're looking for DADT. This is already solved for DADT, so we're ready to roll. Meaning like we don't have to isolate a variable here because the correct variable is already isolated. If the correct variable was not already isolated, then I would have to manipulate this to isolate what I want. Okay, but we're in luck. Right? It's always nice when that happens, when we're in luck. I'll take it. All right, so then I'm ready to plug in. Okay, so I'm going to plug in, and remember, when you plug in, it's off of the specific. So let's just take a moment. Do we know what x is? Yes, it's 7. Do we know what dy dt is when the base is 7? Yes, we do, because that was what we did for part A. We know what dy dt is when the base is 7. So let me maybe just carry some of this information over. We saw from part A that dy dt is negative 7 over 12 when the base is 7. And when the base is 7, we also know that dx dt is 2 feet per second. All right, so like I said, the information, as long as it's consistent with the general, is going to carry over, and the specific. I should say, as long as it's consistent with the specific, the 7 feet. So this stuff is going to carry over all of this from part A. All right, so here we go. Let's play. So dA dt, 1/2. All right, x we know is 7. dy dt is negative 7 over 12. Y we know is 24. dx dt we know is 2. All right, nice. All right, let me just give you a minute to look at that. So now I plug in, and so remember, the plug-in is from the specific. For when this scenario is frozen, the equation is always off of the general when it's true for all time. All right, gang, so let's now fiddle with this. What is this? Negative 49 over 12 plus 48. I'm deciding the fraction on this is going to be a bit nasty because of, oh, well, this is a minus. I'm leaning towards just doing a decimal for this. If you want to do a fraction, that's fine. Let me see how nasty this is going to get. Let me first look at it in fraction form. So if I do 48 times 12 to get the LCD, and I subtract 49, and then this is all over 12. Okay, if I multiply it by 2, it's going to be a decimal. Alright, so let me just finish it up. This one, let me divide it by 12, and then I have to take a half of that. Alright, so what do we got there? That's like 20. Okay, I'm just going to round it up to 22. I don't know what kind of answer the book has. It's about 22 feet per second. All right, so at that moment in time, the area is about 22 feet per second. And it's sort of interesting because we know as the Y gets really tiny, as it gets really close to the ground, the area is going to approach 0. Because eventually it's going to be flat on the ground and there'll be no ladder under it. Eventually the ladder will be touching the ground and there'll be no area under it. But at the moment of 7, when the base is 7 feet, the area is growing. It's a positive rate. It's growing at 22 feet per second. Okay, gang, that is the answer to part B. I'm going to leave this video here. It's almost at 10 minutes. I will come back and look at part C with you. Okay, I hope you enjoyed it. This is an interesting question. Catch you. Bye.